In this video, we will be looking at graphs of basic functions. Our first basic function is the linear function. The domain of the linear function is all real numbers, and the range is also all real numbers, except when the line is the constant function, and then the range is just that number. Our next basic function is the squaring function. When I square -2, I get 4. -1 squared is 1. 0 squared is 0. 1 squared is 1. And 2 squared is 4. So if I plot -2, 4, -2, 4, the point is there. -1, 1, -1, 1, 0, 0, 1, 1, and 2, 4. So the basic graph of the squaring function is a parabola. And it looks something like this. The domain is all real numbers. Again, this goes on forever to the left and to the right. There's no restrictions on our domain. Domain is all real numbers, so -infinity to +infinity. And the range, we can tell from our graph, starts at 0 and then goes on up to +infinity. So 0 is included in that range, so 0 to infinity. Now, when we remember the y = x squared graph so that we can use it later, I want you to remember that it has its vertex here at the origin. We may move that, but our basic graph has its vertex at the origin, and when you move to the right 1 unit from that vertex, you go up 1 unit on the basic graph. When you move right 2 units from the vertex, you go up 4. So keep that in mind. Also, when you're moving left, you go left 1, up 1, and left 2, up 4. And that's your movement on the basic y = x squared graph. Our next function is the cubing function, y = x cubed. If I cube -2, I get -8. -1 cubed is -1. 0 cubed is 0. 1 cubed is 1. 2 cubed is 8. So if I plot these points, -2, -8 is down here. -1, -1, 0, 0, 1, 1, and 2, 8. So our cubing function is a curve that's pretty steep. Okay, if we looked at the next number, 3 cubed is 27, so that's way up there. But our basic cubed function looks like this, has like a turning point here at 0, 0. And then again, when we go 1 unit to the right, we go 1 unit up. But then it's different from the previous graph, because when we go 2 units to the right, we have to go up 8. All right. And then also on the left side, when we go left 1, we go down 1. But then left 2, we go down 8. So that's our cubing function. Our domain on this function is all real numbers, and the range is also all real numbers, up and down. So negative infinity to positive infinity. Our next basic function that we need to become familiar with is the square root function. You'll notice that I numbered my t-chart a little differently because I wanted to use numbers that I could square root nicely. Also remember that we can't have a negative number under a radical because that's not a real number, and when we're graphing only on the real coordinate plane. So my domain is restricted to 0 and then positive numbers. So let me go ahead and write that now while we're talking about it. Domain is from 0 to positive infinity. All right, the square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. And the square root of 9 is 3. So these are some nice numbers that we can plot on our graph. You could use your calculator to get, if you wanted to do numbers other than perfect squares. So if I plot 0, 0, that's here at the origin, 1, 1, 1, 1, and then my next point is 4, 2, so right 4 and up 2, and then 9, 3, so right 9 and up 3. So my square root graph looks like this. Now you might recognize this as half of a parabola. We looked at our squaring function earlier, and if we turn this, you can see that it's half of a parabola. So half of the squaring function. And the reason for that is because squaring and square rooting are inverse operations. All right, so we established that our domain was from 0 up to positive infinity. Our range, as we can see from the graph, is also from 0 up to positive infinity. My next function is the cube root function. And again, I used numbers that I could cube root nicely. Cube root, any odd index, is not restricted as far as the domain goes. So my domain on this function is all real numbers. The cube root of negative 8 is negative 2. Remember, when you cube root, you ask yourself what number multiplied by itself 3 times will give me this number inside the radical. So negative 2. The cube root of -1 is -1. The cube root of 0 is 0. The cube root of 1 is 1. And the cube root of 8 is 2. Now if we plot these numbers, -8, -2, -8, -2 is right here. -1, -1, 0, 0, 1, 1, and 8, 2. This looks very similar to our y = x cubed graph that we did earlier. And that's our cube root function. Let's look at one more. The absolute value function is also a basic function that you need to be aware of. When you take the absolute value of -2, remember what you're asking yourself is how far away is -2 from the origin on the number line. And so we know that it's 2 units away. So the absolute value of -2 is 2. The absolute value of -1 is 1. The absolute value of 0 is 0. The absolute value of 1 is 1. And the absolute value of 2 is 2. So if we plot these points, -2, 2, there, -1, 1, 0, 0, 1, 1, and then 2, 2. Now this one is not a curve, unlike our y = x² that was a curve. It went right 1 and up 1, but then when it went right 2, it went up 4, so that caused it to curve. This one, however, is constantly on the right side of the vertex here. It's going right 1, up 1, right 1, up 1, so it's a constant change, rate of change. So this is a straight line. Well, it's a ray going up and to the right. And then on the left side of the vertex, again, this one's a constant rate of change. It's a decrease, up and then left one. So it's also got a slope of -1, but it is a constant change. So the y = absolute value of x looks like a V, whereas y = x² looks more like a U. Our domain on this function is all real numbers. Our range, you can see, begins at 0 and goes on. So our range is 0 to infinity.